In this video, we'll be learning how to use the horizontal line test to determine whether or not a function is a one-to-one mapping or a many-to-one mapping. Now, let's go right ahead and start with an example. Let's say we're given the function f of x equals to x cubed minus x squared minus 2x plus 1, and we're asked to determine whether or not this is a one-to-one or a many-to-one mapping. Well, to do this, the easiest way is to draw this function's curve. So in this case, the curve would be y equals to x cubed minus x squared minus 2x plus 1. And with our calculators, we can easily plot this curve. And if you do so, you should find something like this. Now, looking at this curve, the horizontal line test is quite simply the process through which we go in which we ask ourselves, is it possible to draw a horizontal line that cuts this curve more than once? And looking at this curve, it doesn't take us too long to see that, yes, we definitely can draw a horizontal line that cuts it more than once. For instance, I could draw a horizontal line right here, and it cuts the curve in 3 points. As a result, we can say that this curve fails the horizontal line test, which I'll write here. Fails the horizontal line test. And because it fails the horizontal line test, we can state that this function is not a one-to-one mapping, and it is a many-to-one mapping. And that's that simple. Using the horizontal line test, we've just shown that this function is a many-to-one mapping. Let's look at another example. Let's say we're asked to determine whether or not the function f of x equals to x squared plus 4x plus 1, defined for x greater than or equal to negative 2, is a one-to-one or a many-to-one mapping. Well, again, our first step really is to draw this function's curve. So that would be y equals to x squared plus 4x plus 1. And in this case, we only draw it for x greater than or equal to negative 2. We can see that that's specified in the question. Now, doing so, we find something looking like this. Now, in this case, can we draw a horizontal line that cuts this curve more than once? Well, looking at this, it's quite clear that no matter where we draw a horizontal line, that horizontal line only cuts the curve once. And so consequently, this curve passes the horizontal line test. So I'll just write that there, horizontal line test. And in this case, because it passes the horizontal line test, this function is a one-to-one mapping over the domain, over x greater than negative 2. And there you go. That's how we can use the horizontal line test to determine what type of mapping we are dealing with.